Good morning. Here I have come with this topic. You can see the topic. Laws of chemical combination means subject is here chemistry. Okay. In the same channel, I am going to upload different subjects like physics, maths, chemistry, biology, and few subjects of mechanical engineering. So here the first topic is laws of chemical combination. This topic you will find in the very first chapter of chemistry of class 11. So there you will find total 5 laws, 5 number of laws are there. The first law is law of conservation of mass. Second one is law of constant proportions. Third one is law of multiple proportions. Fourth one is law of reciprocal proportions. And the fifth one is Gay-Lussac's law of gaseous volumes. Here the first 4 laws relate to mass. Okay, they are related to mass. And the last one, which is called Gay-Lussac's law of gaseous volumes, this is related to volume. Okay, this is related to volume, and the first 4 laws are related to mass. Here in this video, I am going to discuss only the first one. Okay, that is law of conservation of mass. Here in this video I am going to discuss this one. So I think already in class 9 and 10 you have studied this law of conservation of mass. What is the law? We know that the law is stated this way, that mass can neither be created nor be destroyed. It gets transformed from one form to another. So this is law of conservation of mass. So this statement you will get mainly in the book of physics. But in the book of chemistry you will get the same thing. But it is stated in a different way. The way is, in any physical or chemical changes, the total mass of the reactants is equal to the total mass of the products. Total mass of the reactants is equal to total mass of the products. It is for any physical or chemical change. So this way in chemistry the law is stated. But the meaning remains same. Both the statements are equivalent. There is actually no difference. Okay. So for example, in chemistry, how the experiment was conducted to get the proof. As for example, I am showing you, if you take aqueous solution of sodium chloride and silver nitrate. If you take aqueous solution of sodium chloride and silver nitrate, then after reaction you will find what? You will find sodium nitrate and silver chloride. You will get a Carzi precipitate of silver chloride. Okay. So how the experiment was conducted? First, sodium chloride and silver nitrate both are taken in conical flasks and their weight together. Okay, with the flasks, they are weighed together with the flasks, and after reaction the products are what? Silver chloride and sodium nitrate. These are the products, silver chloride and sodium nitrate. Again their weight by using a weighing balance. Okay, so experimentally it was found that before the reaction, okay, the total weight of the reactants was equal to the total weight of the products. So this way experiment was conducted, and if you take any number of reactions, there are thousands of lakhs of reactions, or there are millions of reactions there actually. Okay, so in any case result is always the same. Okay, so I am going to show you the reaction here. What was there? Sodium chloride NaCl, okay, plus what was there? Silver nitrate, AgNO3, okay, and the product was, these are the reactants, okay, and the product was AgNO3, precipitate was there, and what was there? NaNO3, NaNO3, okay. So this was the chemical reaction. This is the reactants, these two are the reactants and these two are the products. So weight of these two is equal to weight of these two. So this way experiment was done. But so in chemistry you will find this law of conservation of mass. But there is one problem, that there is exception of this law also. Okay. According to Einstein's theory of special relativity, he showed that E is equal to mc square. I think this law is known to you. E is equal to mc square, where E is equal to energy. Capital E is energy, small m, this is mass, and this is small c, this is velocity of light. You know velocity of light, it is 3 into 10 to the power 8 meter per second. Velocity of light is this much. Okay. So, according to this law, mass and energy both are interconvertible. Means one can be transformed into another. Mass can be transformed into energy. Again, energy can be transformed into mass according to this law. And experimentally it was found that this is true. Okay. So, this is exception. So, here mass can be destroyed to get energy. Okay, according to this law, mass can be destroyed to get energy, such as in case of nuclear bombs. Okay, their mass is converted into energy, and that way tremendous energy is formed. Okay, but in case of ordinary chemical reactions, in most of the cases, all the reactions are ordinary. Okay, so in case of ordinary chemical reactions, during the experiment, actually during the reaction, some energy is released, but amount of that energy is very less, very small. Amount of that energy is very small. So if you neglect that much of energy, actually there will be no problem in case of calculations, okay, or in case of experiments there will be no error. But practically there is some release of energy during chemical reactions, and since release of energy is there, therefore the release of mass is there. Okay, means there will be some reduction in mass during chemical reaction. So, but yes, there is reduction, but that can be neglected since amount of energy is very small. Okay, so equivalent mass is mass equivalent to that much of energy, that is also very small, and that can be neglected at ease. Okay, so this was the law of conservation of mass. Once again I want to state the same thing. Mass can neither be created nor be destroyed. It gets transformed from one form to another. This is conservation of mass principle. Again, the same thing can be stated this way also. In any physical or chemical changes, the total mass of the reactants is equal to the total mass of the products. Okay, and in case of, if you want to use this law, so statement of this law is what? According to this law, the sum total of mass and energy remains fixed. Sum total of mass and energy remains fixed. Okay, so that is the modified law. That is actually modified law. Okay, anyway, now you know this law, but in case of chemical calculations, in chemistry you have to do calculations. Okay, numerical calculations. In all the calculations you do not use this one. Okay, always use this one, law of conservation of mass. Assuming this, you have to go for all the calculations. Okay, so this is the end of this video. Thank you. for watching this video. Have a nice day.